video, we are going to discuss about Ferrari's method. Why? We can solve biquadratic equation easily by this method. So let's begin with an example. Here is an example. So x to the power 4 minus 10x cube plus 35x square minus 50x plus 24 equals 0. We can rewrite this as x square minus 5x because the coefficient of x cube is minus 10 and half of it is minus 5. Plus we are introducing a new constant lambda, the whole square. Now all the terms, rest of the terms take to the right hand side. So that is minus 5x square plus 50x minus 24. So we have introduced to lambda. For that there is two extra terms. That is, if we break down these whole square terms, then we will get x to the power 4 plus 2 times x square into minus 5x plus lambda plus minus 5x plus lambda whole square. So we have two more terms, that is this one, and another is 2x square times lambda. So let's put these terms on the right hand side. So therefore 2 lambda x square plus minus 5x plus lambda whole square. Okay, or we can write this as x square minus 5x plus lambda whole square equals x square times minus 35 plus 2 lambda plus 25 x times 50 minus 10 lambda and then plus lambda square minus 24. Or we can write this as 2 times 2 lambda minus 10 x square plus 10 times lambda 5 minus lambda times x and then plus lambda square minus 24. Name it equation 2. To make right hand side perfect square, we must have 10 times 5 minus lambda whole square equals 4 times 2 lambda minus 10 times lambda square minus 24. So 100 times lambda minus 5 whole square, 4 times 2 times lambda minus 5 and lambda square minus 24. Or we can write this as lambda minus 5 times 2 lambda square minus 48 minus 25 lambda plus 125 equals 0. Or lambda minus 5 times 2 lambda square minus 25 lambda plus 77 equals 0. So if we solve for lambda, we'll get lambda equals 5, 7 and 11 by 5. Choose any one from these three and you will get the same answer for any of these three. So for lambda equals 5, equation 2 becomes, you see, this is our equation 2. Now if we put lambda equals to 5 in this equation, we will get x square minus 5x plus 5 whole square equals, this will get 0 times lambda is x square, this will also get 0, and from here we will get 1, or x square minus 5x plus 5 whole square minus 1 square equals 0, or x square minus 5x plus 6 x square minus 5x plus 4, or we can write this as x minus 2 times x minus 3, and this one x minus 1 times x minus 4 equals 0. So therefore x is the 1, 2, 3 and 4. Another example solved by Ferrari's method. Consider the example x to the power 4 minus 6x square plus 16x minus 15 equals 0, and name it 1. And this equation may be written as x square plus 0x, because there is no x cube term, so coefficient of x cube is 0, so therefore 0 times x plus lambda whole square minus mx plus n equals 0, where m, n and lambda are constants. So we can write this equation 2 as equation 3. Now equating the coefficient of the like power of x of equation 1 and 3, we will get this minus 6 equals 2 lambda minus m square, and 16 equals minus 2mn, and minus 15 equals lambda square minus n square. Okay, so now from here m square is 2 lambda plus 6, mn is minus 8, and n square is this. So if we put the m square n square value in this equation, m square n square value, then we will get this equation. 2 times lambda plus 3 times lambda square plus 15 equals 64. And if we simplify these things, the equation becomes x lambda cube plus 3 lambda square plus 15 lambda plus 13 equals 0, and lambda equals to minus 1 satisfy this equation. So therefore lambda equals to 1 is a root of this equation. So when lambda equals to negative 1, then m square is minus 2 plus 6, that is 4. So m square is 4, and therefore m is plus minus 2. Again lambda is negative 1, so lambda square is 1, 1 plus 15 is 16. So n square is 16. So or n is plus minus 4. Another important thing is mn is minus 8. So since mn is 8, so we can have two pairs, possible pairs, that is when m is 2, n must be minus 4, or when m is minus 2, then n must be 4. So now the equation 2 becomes, here equation 2 becomes x square, lambda value is negative 1, so x square minus 1 whole square minus mx plus n. So if we choose this pair, equation 2 becomes x square minus lambda, so lambda is negative 1, minus 1 whole square, minus m is 2, mx 2x minus 4 whole square. So from here we can easily see that if a square minus b square, then that can be written as a minus b and a plus b. So similarly here lambda square, x square minus 1 plus 2x minus 4, and x square minus 1 minus 2x plus 4. And similarly, we can write this as the product of two quadratic polynomial. And we can easily solve this by Cedar-Acharya formula. So from here, x is minus 1 plus minus root over 6, and from this equation we get 1 plus minus iota root 2. And these four values are the root of the given equation